Thank you so much. I'm Sushma Sardana, and I'm a teacher trainer at MIT University, Delhi, Noida, UP. And at the same time, I'm pursuing my education as a PhD scholar at this age from the same place. Before that, I have taught for 31 years in Delhi Public School as a biology teacher. So today I'm here to discuss one of my favorite topics, STEM education, and how is it being enacted in schools of India. So if you permit me, ma'am, can I start?
Yes, ma'am, please.
Yeah. So in past few years, since new NEP has been launched, we are talking a lot about integrative approach, whereby the focus is to promote holistic and quality education to school going children. The suggestions have been made by National Curriculum Framework in 2023 to focus on multidisciplinary knowledge, develop competencies such as skills, uh, creativity, critical thinking, collaboration, communication. Apart from that, NEP also recommends instilling values, developing progressive attitudes, and contextualizing Indian culture. One such integrative, multidisciplinary approach is STEM education that we are going to talk about. So, how it is being enacted in our schools and what do we need to make it better is agenda for today. So let's begin from the beginning. What is STEM education? As you can see on the screen, it is a combination of four disciplines: science, technology, engineering, and maths. It is actually a way of teaching. It is a teaching approach, I would say. This acronym actually is a very good example where we can say it is much more than its combination. And what do we mean by this? Before that, we should know where it originated. It originated in USA in 1990, around 1994, I would say, to be more precise. And though the whole world is adopting it now for its utility, the knowledge and basic principles from four disciplines are contextualized to construct their knowledge, to devise solutions for real life problems in a collaborative manner. The process is such that the learner is supposed to develop the four competencies that our NCF and NEP is talking about. So in a way, I should say that there's a great connect between the STEM education, which had been discussed and originated in US, and what we are talking now in terms of our policy, our education policy. If you are an educator or if you're dealing with the schools in India, you would know that STEM is quite prevalent in our schools, but in different forms. For example, in pre-primary level, we call it STEAM. STEAM means where arts is integrated along with the STEM. And in classes 9th and 10th, we have art integrated projects in sciences as well as in other subjects, which means again we are integrating the knowledge. Use of technology is compulsory in all the spheres, especially after pandemic. Everybody knows about technology. And many of the Indian schools are integrating ICT in their curricular transactions even now. So which means we have almost all the components around. Now, integrated STEM is the most popular, most well-known model of STEM. And even at higher education level, we talk about it, but at school level, we are still, you know, I would say in initial stages. So let's summarize whatever I said just now about STEM, that it is it's a approach which unites the knowledge from science and mathematics to design solution to real life problem while leveraging technology. So all the four things are covered here. Capacities and skills developed in youngsters while following this teaching approach are necessary for future jobs and to live in harmony with other citizens on this globe. That is its utility part. So, as I told you, I'm doing my research and I've been a teacher. So, I've been visiting a lot of schools. Many teachers claim that, you know, their classroom activities include everything that describes STEM. This acronym STEM, all the four parts, they claim that everything is there. They are using those innovative pedagogies. They are doing a lot of hands-on learning, and they are doing projects. Then it means they are already doing STEM. So my contention is that no doubt we are following all the components here, but there's one very, very important component missing. One, that we are still following silo disciplinary, monodisciplinary method. We all are teaching one subject at a time in our classes, right? Secondly, to enhance understanding, we are using our technology. We are observing day to day natural phenomena. We are trying to understand the global issues. We are even understanding the impact of those issues in our lives on world economy, everything we are doing. But again, one major component which is missing in Indian education is the engineering component. We are just short of designing solution. Here I've given one example on my screen that if I'm a science teacher, then I'll make my children perform certain experiments. Let's say they are finding out this, they are trying to understand what is acid rain and what is its impact on the local crop, how it is impacting the crop yield. But a STEM student will go just one step ahead, and he or she will use this whole knowledge only at the research stage and then design product or a strategy or a process to reduce the detrimental impact of stem, this acid rain on the crops. So that part is missing. I'm not saying that we are not doing it at all. There are some schools which are following the project method very aggressively and they are coming out with prototype. So there are some schools which are following STEM. So let's talk about the components of STEM briefly. When you talk about science, yeah, we all are science people, and with various branches of science, we are trying to make our children understand the conceptual understanding of scientific principles and integrating it with technology and mathematics at times as and when it is required. But what exactly are we doing in science? In the name of hands-on activities, we are following a certain curriculum, a preset curriculum, that these are the number of experiments I need to finish because children are going to be assessed in the final examination. So there's a uniformity in the procedure. The results are quite predictable. The way we present, like in files or whether the child demonstrates, makes observation table or charts, everything is absolutely uniform and expected. And the rubrics are created accordingly. So basically, we are explaining the concept. We are explaining, some particular thing, but we are not making them design a solution. We are not testing their critical thinking skills. We are only making them learn certain things. So that is what science means here in India in STEM. Now, coming to technology. Technology doesn't mean just the digital part. It may even be non-digital part. Technology is something which makes life easier. Okay. Even a locally available, inexpensive resource, if it is used to enhance the understanding of a child, that will be a technology. In fact, in STEM classes, the students learn how to use the technology, they develop certain skills, and later on, they may even generate technology. They may develop such technology which will, which will help the people or nation to progress. So that is technology in STEM. When you talk about technology in schools, many schools are offering coding classes. They are setting up labs. I think many schools are also offering computer science and they teach them different computer languages like Java, like Python. So, depending upon what level they are. And even in summer courses, summer camps, they call it STEM education and they are doing. So, what I would like to clarify here that these are the digital skills, the skills which a STEM educator and a STEM student may possess. They are welcome skills. They may be possessed by these people to enhance the understanding, to design the solution. But they themselves are not STEM. They are just one part of the STEM. Another thing is engineering, the sore point, which I've been discussing. Now, engineering doesn't mean the engineering as a subject. It means they are the glues, they are the integrators of others. They are the designing steps for the solution which a educator will make the students follow. So when in a class and you want to understand whether you're following STEM or are you doing only science, you should ask yourself, are your students working like an engineer? Are they following the process an engineer would follow if posed with a challenge? And what are the steps they are following? So this engineering design process, which is a very, very orderly, very, very systematic way of approaching a problem and designing a solution, more or less we follow these steps, but they may not be in the same order. So let's say I've taken my children as an educator, I took my children to a nearby pond, which is stinking. You can see certain things floating, plastics. The color of the pond is green, eutrophied, and the people around, the villagers around that pond are falling sick because of malaria or they are falling sick because of cholera. You have taken your children. Now, next part is the ball is in their court. Now, they need to identify and define a problem. Are they able to do it? Then, are they able to work as a team and brainstorm the solution to the problem which they have identified? After that, when they are finding a solution, are they thinking about the various constraints like how much time you have given them, what resources do they have, what skills do they have, is it feasible to carry out the solution, are they being practical in in their thoughts, and finally whether they select one of the solution which has all the qualities. Once they have selected, they act upon it. They produce a prototype or a strategy or a process which is supposed to solve that problem. Then they go ahead and test that solution. If they find a deficiency, they accept their failure. That is very, very important, accepting one's failure and try to sort out that deficiency. And once again, they repeat the whole process. After whatever number of attempts, if they solve it, they find a solution. Now comes the communication part. How well they communicate, how clearly do they communicate, to the stakeholders which they have decided, whether they are the general world, whether they are the teachers, whether they are the students, whether they are the villagers, are they able to communicate to them? So these are the processes which we need to work upon as educators in India. We have to get our children used to it. Lastly, mathematics. Mathematics nowadays is called mathematical skills and computational skills in our schools. Very soon we'll be calling upon that. Why? Because mathematics is an integral part of STEM, whether you are using technology or engineering. See, you need to compute the results, you need to analyze your data, you need to even when you present your solutions in the form of charts or models, you need mathematics. So the basic knowledge of mathematics is necessary if you are designing a solution most of the time. I'm not saying all the time. Mathematics is a very, very important part. So NEP and NCF both are talking about this kind of approach, though the word STEM is not given in this document, but whatever I have discussed so far is being discussed in this document. This is how our curriculum is designed. See, we are here at the school level part. So under the guidance of NEP and NCF, when they make those nested academic standards like aims of education, curricular aims, curricular goals, etc., that generates the ideas to have curricular areas. So we have a lot of changes in the curricular areas. In the near future, we will be having some interdisciplinary curricular areas like environmental education, design thinking. We will be having individual in society. So along with rest of the sciences and maths and everything is going to be there. So there's a lot of scope for STEM and we have to train our children accordingly. Then how they are going to be enacted, that depends upon this, the school culture and processes, which means the infrastructure of the school, what mission and values the school wants to instill, what kind of attitudes will be developed. So this now it is in the area of school, how STEM will be enacted. Okay. And there are some supporting documents which are, which are there to promote these innovations in the school. Basically, they are hand-holding documents, how they will give us concrete guidelines to bring it in, that research which they have done, how to practice it. So the teachers are going to be trained in these things very soon. And I'm also one of them that I'm also trying to do the same. So let's summarize whatever we have discussed so far. So basically in India, STEM integration is a very, very new phenomena, I would say. Though in past, in ancient India, we have done a lot of STEM and a lot of achievement, only the names are not given. NEP and NCF is talking about multidisciplinary approach and to make the STEM education personalized, what we call differentiation, to develop the 21st century skills in the children. And they talk about pedagogies, they talk about books, they talk about whole curriculum. Only thing is that interdisciplinary curricular areas, how they are going to be enacted is another thing to be seen. As I said, that different schools are following different models of STEM. So soon I'm going to talk about that. Now, when I say about STEM models, you see, a teacher teaches the way he or she perceives a subject. So most of us have studied STEM disciplines in our colleges, in our college degree, in a silos manner. So our perception of STEM would be accordingly, especially till the time we are trained for it. So right now, when I take, tours to the schools, I realize that teachers are teaching the STEM. They are claiming they're teaching the STEM, but they're teaching in the way they perceive. For example, one of the model which I've noticed is STEM as acronym. It's a very traditional way of teaching science and mathematics in separate classrooms. And even the technology part is missing. So many schools which do not have ICT infrastructure, they are following this particular kind of model. Then there are another type of schools where they are teaching all these subjects, especially in science, they do use mathematics and technology. They show video games, they use video clips, they use animations, okay, and they even have certain apparatus which are digital, or they use a lot of lab material. So the technology is there. Mathematical computation is there even in assessment. If you look at the board papers of class 12th and 10th, you will find interdisciplinary questions. And of course, the project, as I've already discussed. So they are using technology, they're using a bit of engineering, not optimized, and mathematics in science context. So that is the second one. Third one. Second one is real world problem. If you notice, our textbooks have a lot of example from real life. So many teachers use those examples and enhance it by using more examples from their local scenario. That is the second one I have discussed. And the last one, which I said that, which is the most popular model, I would say, in the public schools, which have good infrastructure of ICT, there they are offering all the subjects, but they are teaching them separately by separate teachers. There is more and more specialization. Of course, a lot of emphasis on ICT. So these are the models I've noticed in India so far. Uh, I will not discuss challenges for the teachers. Ma'am, how much time do I have?
Ma'am, it's already 11:23. If you can,
Okay.
yeah.
So I will stop here and I will discuss rest of the things only if there is some question based on that.
Yes,
Otherwise, I'm done. Yeah,
yes, please. If you can stop sharing the screen, please.
yeah, yeah, I will. I will. Yeah.
Yes, ma'am. So there are some questions prepared by me, ma'am. As no audience, I don't see any audience for this
Hmm,
session. I will ask the
hmm,
same to you.
hmm.
Okay. So you have just you were about to present the challenges. So I'll continue from that question. What are the
Hmm.
key challenges faced by schools in India in implementing effective STEM education programs?
So if you talk about challenges, uh, basically the teachers are not able to understand the meaning of STEM. That is very, very surprising. But we have to accept the fact that the teachers are new to this concept. So initially, when I took a poll of 100 teachers from a very well-known public school, I realized that they do not understand meaning of the STEM, though at least 25% of them understood the just the acronym they understood, but they didn't understand the meaning, especially the engineering part. So first of all, they don't understand. Secondly, even if you make them understand, like I did an experiment with my pre-service teachers in MIT, and they could not write a lesson plan where they could integrate everything. So I had to tell them that you don't have to integrate all the four disciplines in one lesson plan. Even if you do it, maybe more than one, let's say two at a time. And in each concept, you can integrate different disciplines. That is the second challenge. Third challenge, relating to real life. Whatever is given in your book, whatever context is given in the book, they are able to do it. But adding it from their own side, they need a bit more confidence. So they have to look around themselves, integrate the local problems in their teaching, and design certain unpredictable result experiments or projects. Even if it means not reaching a solution, at least give them a practice of thinking, critical thinking, practice of computing. So every time we don't have to reach a solution, but we need to give them a practice. That is where they need more confidence and hand holding. Fourthly, I realized that some teachers are using a lot of activities in the class and they say, oh, we are doing this STEM lesson. It is a science forward lesson. It is not actually STEM. STEM means finding solution, using all this. So these are major challenges, ma'am, faced by the teachers.
So, then how can teachers be better equipped and trained to deliver STEM education effectively, ma'am?
Yeah. So that brings me to the agenda of teacher training, which we need to do very aggressively, especially when we want to implement our NEP effectively. Now, when you say about training of the teachers, number one, we have to work on our curriculum, which we are doing. Already, as I said, there are some interdisciplinary curricular areas which are, which are being designed. The books are being designed in various languages also. In one of them, we are even working on the sociological aspect of the science in individual and society, where we are trying to sensitize the children to the ethics which they must follow. Knowing science doesn't mean that you can go ahead and do anything. You have to think about your neighbors also. You have to think about society at large also. Environmental education. So instilling the values of environment, instilling the values for human beings or constitutional values, that is also part of our teacher training. If you teach them, you're training your teachers, then you also have to train them how to assess them, how to look after the diverse kind of learners, how to incorporate the experiential learning, how to incorporate the collaborative learning. So these are specific deficit area which we have to work upon. Then another thing, teachers need to be creatively adaptable. They learn to use the locally available and economical resources rather than asking for expensive stuff. That way we will never reach our goals. And lastly, we have to work on our 21st century skills because they will generate the employability for all of the, our young learners. So these are certain things. ICT, everybody is already working, so I need not talk about it more. The teachers, once they have got their B.Ed, they must go on learning more and more using open access resources like MOOC. There are so many new courses coming in India as well as abroad. So these are the things which we have to instill in our teachers right from B.Ed onward. These are my suggestions, ma'am.
Okay. So, ma'am, you are into research, right? And can you mention any some of the successful models or case studies of STEM education implementation in Indian
Oh,
schools,
great.
other
Definitely,
institutions
ma'am.
can learn from? Yeah.
I wouldn't name any school because it's a public platform. I
Okay.
know I'm only appreciating them. But even in Delhi, when I'm doing my data collection, I am going to many schools. In Delhi itself, I could see some very example which are worth appreciating. But I can definitely name one institute here, and it's my great privilege that I worked with them for some time. This is a Center for Creating Learning at IIT Gandhinagar, where I went for a workshop, and I realized Professor Manish Jain doing a great job. He invites the school teachers, and he shows them various locally generated toys by their team. Very inexpensive toys. You can carry them to your schools and make the children do the same while learning the scientific principles. And he focuses a lot physics and maths, which is considered most difficult part of the school education. And I did give them suggestions, sir, do include some biology also. So he included a nature walk also, and in which we learned many, uh, you know, interesting things which are not given in our textbooks, relevant to us. They are relevant to our real life. So these kind of workshops should be done for school teachers. And in Gujarat, many schools are following it. All over India, actually, we are following him. We used to have his webinars in our schools. So many of our schools are following STEM education, but because the curriculum is yet to come, the new curriculum is yet to come, the new books are yet to come, so we are waiting. And such things can be included in a curriculum in the form of projects to begin with. You cannot go all the way, and start integration in all the schools at the same time. We have to take one step, one small step at a time. So that is what I would suggest. And these are interesting things, and soon I should be able to publish also. There is one more case study which I published in my one of my papers, where I used an Indian context, very small thing, जैसे मिट्टी का दिया होता है मैम. I used that diya, which we use in a puja, to create a context for science students of class 7. And from then, we connected it to their history lessons, we connected it to their science lessons, and we managed to teach everything that is given in a curriculum very successfully. And children in rural area as well as in urban area were able to understand only the examples given were different, because we have to connect our knowledge to the real life. That was we did.
Thanks, ma'am. So what measures can be taken to spark and maintain students' interest in STEM fields from an early age, ma'am?
Well, I wouldn't say students fail, we fail.
Okay.
Number one. So students, nowadays government is doing a lot of competitions, a lot of Olympiads. If you notice, government of India is all over the place, sending us circulars into the schools. We have to do it honestly. If we do it honestly, we are there. Then we had this Indian Science Festival recently in Delhi, in Faridabad. Many schools participated. So that is what I'm saying. Do whatever you want to do within your resource, but do it honestly for the children, not to show any media presence. That is what my message to all the school leaders and the school teachers. Of course, we need all that in public domain, but children are the first receivers, and we must look after our learners.
Right. So, ma'am, coming to the assessment, how can assessment methods be adapted to better evaluate students' understanding and skills in STEM subjects, ma'am?
Oh, we already have it. Competency based assessment we are already doing. We are doing case study based. We are doing MCQ. How you design your questions, that is where you have to, you have to develop a particular kind of rubrics. And you need not do only on paper and pen. A lot of things can be done through observation. You leave your children and you're observing how they are maintaining, how they are doing their project, how they are doing their teamwork, how they are presenting their work. Everything is not on the solution, that whether they found the solution through the problem. Look at the engineering design process. Every step is important. So the teacher is there watching them. She's a facilitator, she's an observer, and then she's an assessor also. Another thing which I really want to emphasize, which should be done authentically in India, is peer review. The peer appraisal, peer review is a very important tool which we are not optimizing enough. After that, only the teacher appraisal should be done. Because at peer review level, the student, without getting boggled down by the marks, is able to accept one's failures and reiterate, just go on changing one's aspect of finding solution. So that is where the assessment lies. Okay, assessment should not be only in the hand of a teacher. It should be like a group of teachers so that bias can be removed. So observation, making proper rubrics, informing the children about rubrics, and then following different ways of assessment, which includes different type of questions, and all these things can be included. It should not be one. So more or less, I would still advocate that CC, comprehensive and continuous evaluation part, which we did long ago, but with a little twist, we can do right.
Right, you should continue. So, ma'am, last question but not the least. What future trends do you foresee in STEM education, and how should schools prepare to adapt to these changes, ma'am?
Well, I'm very optimistic. Our Indian teachers are very adaptable. Whatever, recently I went to Chicago and observed one of the schools over there, and I came back and I realized within 1 month the teachers adapted so well. Even my own student in MIT, they did a great job. So in future, we see India competing with the rest of the world, no doubt about it. I have full trust, full faith in my school system, and our children, our learners, they are all over the places. So we only have to encourage them. Very soon, our schools are going to be ICT trained, all the stakeholders. We are going to have all the new kind of material thanks to Professor Jain. And of course, other NGOs which are working in a similar manner. And of course, the teaching trends are changing. The teachers are getting aware. They are doing more courses. Government is so much supportive. So I think we are only going towards progress. And of course, the assessment pattern is changing.
Great, ma'am. That is the end of our session. Thank you for the talk and for patiently answering all the questions, ma'am. Any message, anything else you want to mention?
My only message is whatever you do it with passion. That is all. Otherwise, things may fail. We are not judging anybody, we are judging ourselves. So look at yourself and decide whatever I'm doing, am I doing it right? If you are doing it, your work properly, then nobody has to bother about telling you how you have to do it. You are your own judge. Whether it's a student, whether it is a teacher, whether it's a school leader, whether it's an NGO. We should have autonomy and we should trust ourselves. That is what.
Right, ma'am. Thank you for the wonderful message. We'll stop the recording and end the session, ma'am. Thank you.
Yeah, thank you.